Thank you to everybody for joining us today. As mentioned, my name is Sean Gardner, and we're pleased to share an introduction to the command and control software developed by Autonomous Solutions Incorporated. More commonly, we're referred to as ASI. We currently develop and test at a location in northern Utah with our own tracks, offices, and mechanical shop. This image you're seeing is our location. We have expanded somewhat since this photo was taken, but it's representative of where we operate. Mobius is the name of the command and control software that we've developed. And this meeting is geared towards demonstrating some of the Mobius features and how it might provide you with the opportunity to improve your consistency and reliability in test results. Because every proving ground is unique and testing needs may be dynamic, Mobius was developed with the intent that users should be able to develop their own tests without having to enlist a team of coders to define the parameters of the test. Mobius has a number of functions, and the first I'd like to introduce you to is the Map Builder tool. With this tool, a vehicle can be driven around the perimeter of stackable shapes to define what the vehicle's drivable area will be. So Mobius has let's see, I think I've covered that, but Mobius has a number of functions. This is Map Builder, and with this tool, a vehicle can be driven around the perimeter of desired tracks or areas to geofence a drivable area. The user can create these shapes and define what drivable speeds will be by assigning an area speed limit. In this case, you can see that we do have 3 points on the vehicle that is being recorded. We can record from driver's side, passenger side, or center of the rear axle, which we consider to be the control point of the vehicle. We can record a shape as the vehicle drives from any of those 3 points, and then we can assign different shape types once the shape has been driven. We can also assign a speed limit, as you'll see once I change this to a drivable area. If you're not happy with exactly how the shape is driven, you can also edit the shape manually once it has been driven, or alternatively, you can draw shapes directly. The speed limit that's assigned is not going to drive the vehicle at that speed like a real-world speed limit. It's simply a limitation on how fast the vehicle could potentially go in that shape. Here I've marked the inner shape as an obstacle. The outer shape remains drivable and creates our track. The vertices you're seeing now can be manipulated individually by hand to determine the shape, the consistency of the shape, and whether you want to change anything on that map. So here, Mobius has a number of, well, let's see. I apologize, my screen didn't change. When multiple vehicles are driven on a map, there may be instances where vehicle speeds come into conflict with one another. In the case of this video, you'll notice the blue car, which is in the lead, moving up into the serpentine path now, is actually commanded to drive slower than the red car. The red car is intended to drive up to 40 kilometers per hour through the serpentine path. But because Mobius maintains a safe distance between autonomous vehicles, it has to follow at the slower speed. This can often interfere with the operation of a test, and so Mobius does provide a solution to this issue. The Mobius map shapes allow a user to determine speed limits and vehicle occupancy. That's not persons in the vehicle, but how many vehicles may be in the shape. Mutually exclusive access can allow a slower vehicle to complete an event before another can enter that section of track. And here you'll see that I'm able to draw a freeform shape on the map. I can simply draw a block over the area of that serpentine path. And when I do create this new box, I define the shape as having the same maximum speed limit as the track itself. But then I also add a maximum occupancy limit. And in this case, that's the limit vehicle access. And typically that's going to be only one vehicle. But then I need to identify the shape It's not going to interfere with the operation of vehicles within this shape, but it will limit how many vehicles can be in the shape at any given time. Now, with that shape in place, you can see just the outline of it there over the serpentine section. As that lead vehicle enters, it takes up the maximum occupancy limit. Looking at the red vehicle below it, you'll see that it currently has an orange halo, which indicates that it is slowing or stopping for some event ahead of it. The red vehicle will actually stop before entering this section and beginning its run through the test event until that blue vehicle has exited the area. Once the blue vehicle exits, the red vehicle will be free to enter and conduct the test at its own designated speed. I could give it a minute longer, but the red vehicle will simply, you'll see it enter the block once the blue vehicle leaves. If you watch the halo on the red vehicle, it will clear to blue, and the vehicle then proceeds to enter the event and drive at its own speed. So along with being able to create maps, Mobius gives us the ability to create specific paths for the vehicle to drive within the geofenced drivable area. Once the path has been created, there's a host of editable functions that the user can use to dictate how the path will be driven. These could include acceleration ramps, deceleration ramps, actual stops, and direct actuation overrides. To create a path, it's very similar to the way that we create a map. You'll see here I have a vehicle on the drivable shape. I can then command it to record a path. We don't have the option of 3 different recordable points when we're creating a path. The reason for that is the main pivot point will be the center of the rear axle, or in the case of larger vehicles, in the center of the rear axles. And that's the pivot point. That is the point that is going to be tracked against our designated path. In order to drive a path, we simply need to, we can draw a path manually, or we could record it. This is an example of the manual drawing. Once the path is drawn, it can be edited. Curvatures can be added and modified, as well as the speed being modified. Once you're happy with the path, you can begin to add any customization to it that you like. In this case, the speed limit will drop from 65 kph to 40 kph. Alternatively, I could use a different type of event, which would be changing it to a user confirmation. This will command the vehicle to stop and wait until such time as the user gives it permission to proceed by clicking on the notification. We can also assign a label to this so the user understands why it has stopped and that they need to take action to command the vehicle to continue. Then we can change the speeds again. Once this path is published, the vehicle can be assigned to drive it. It's that easy to create a new path for your own testing procedure. So Mobius drives the vehicles very specifically, and that can often cause concerns about wear and tear on a test event. So Mobius gives us the ability to drive within a 3 centimeter tolerance if we just assign it to the designated path, and it will run very close to that. There's always some variance in the vehicle, but it's commanding the vehicle to drive back within that 3 centimeter tolerance at all times. In the center panel here, you can see we have the ability to introduce some random variability. In this instance, I have assigned a 1/2 meter tolerance. And Mobius, as the vehicle makes different paths, will step off of the main path within that tolerance to prevent wear and tear occurring in the very specific location. We also have incremental variance where you define a window and you can then determine how large a step it will take off of the main path. and it will do that progressively so that you do cover a much broader area of pavement without damaging anything. Both of these are functional. Both of them can work to your advantage. The incremental just gives you even finer control over how you would like to modify that driving area. Mobius also has the ability to teleoperate a vehicle. Using Xbox controllers, you can drive the vehicle remotely. We would suggest that you use cameras if you want to do so, so that you're not relying solely on what appears in Mobius, as other vehicles, animals, or obstacles could be present on the track. Typically, Mobius is used in closed environments, such as proving grounds, so that's not typically a problem. But if an operator is going to be driving the vehicle in areas that are not typically designated for that purpose, they'll want to have cameras in the vehicle. But Mobius uses a dead man switch to allow for operation. If you notice, the clutch pedal in this case is designated as the dead man switch. If that switch is released, the vehicle will come to a very quick stop, so the user can engage or disengage at their will. This dead man switch also creates another unique opportunity in Mobius, which is that we have supervisory control. So if a vehicle will be traveling on a roadway within the proving ground where there may occasionally be mixed traffic, a user has the ability to command the vehicle to drive, but must hold a dead man switch in order to enable that driving. This isn't the standard, but does provide a unique opportunity for supervisory control. One of the features in Mobius that is not that controls multiple vehicles would be our convoy. This convoy function allows for a single vehicle to follow a path, whether driven manually or remotely or following a designated path, and up to 9 vehicles can then follow that leader on the path. The distance between them can be designated based on a distance function, or alternatively, it can be set up with time spacing. Yes? Was there a question? Maybe it was just an echo. So the convoy function is simple to set up. We have, in this case, 4 vehicles. We'll put them in the convoy assigner. Vehicle 1 is in the lead and is the blue vehicle. That's designated to be the convoy leader. Then I click on the button to establish convoy. Once the convoy is established, I click on the play button below that so that the other vehicles know they are ready to drive. And then in this case, I will assign the lead vehicle to the path. The other 3 will follow him. And as the vehicles begin driving, you'll see, once I highlight one of the red vehicles, you'll see that the spacing on them begins to spread out. In this instance, they're assigned to maintain a 100-meter spacing. And I believe the tolerance for that, the desired tolerance, is typically 3%. In this case, you may notice the second vehicle is trying to catch up. It's just a little bit behind. The third vehicle is a little bit behind, is still allowing the space to build. But once the vehicles have established, in this case, that 100-meter tolerance, even though the lead vehicle may fluctuate in its speed, the others will make accommodation and follow at the designated intervals. I'm switching between vehicles so that you can see the gauges between them. The bottom section of the gauges is where the spacing is indicated. But Convoy creates some unique opportunities for driving in some conditions where you might not otherwise expect to be able to operate a vehicle. Let's see. Specifically, when I say that, I'm referring to dusty or dirty or dark track conditions. We also have a feature in Mobius. Many proving grounds will have multiple paths that they want to run in the course of a single testing event. We do have a path playlist function, which will allow you to build a library of paths and conduct those tests in the order that you want, repeating which paths you want to. If you do, it allows you to conduct multiple tests throughout the day and run without an operator having to continually assign each individual path. This slide, this video, is an example of Path Builder in action. First, we create our playlist. I'm sorry, not Path Builder, but playlist. We create our playlist function here. We have a number of paths. I can assign, in this case, that oval to drive through twice. I then move the vehicle into the playlist assigner. I can select a playlist from a drop-down list. My recording function doesn't capture drop-down lists as they're not part of the main screen. I will acknowledge warnings, which simply say that some of the connecting paths are longer than the configured tolerance for expected connection. I can select a number of cycles that the vehicle would run through this course, or I can tell it to run infinitely so that it can just continually run throughout the day without having to stop for any user comfort breaks or operator breaks. The vehicle can continue to drive and will transition from one path to the next. You'll notice that we have the solid lines on the designated paths, and then we have dotted lines, which are the connecting paths that Mobius has built, independent of user interference. You can see here that it will adjust and connect to the next path. It would do this all day if we allowed it. You'll notice in the near center of screen in the column with the purple lines, those are giving us the status of the playlist, the vehicle's progress in any individual path, the vehicle's progress in the list of paths, and the current estimated time to complete the path. Another feature that is one of our newest and perhaps most exciting is ADAS swarm testing. So with ADAS swarm testing allows you to create prescribed test scenarios that define the time and position of each vehicle in the course of the path, and allows you to test your modeled responses of an automated vehicle or an ADAS capable vehicle in a real world environment with live vehicles moving around it. The swarm testing, as we call it, is a multi-vehicle host-centric test. We will typically, I'll show you another video here in a moment detailing a little bit more about it. But there are a couple of patented features we have, one of which is we refer to it as safe stop. If any vehicle in the swarm encounters any kind of error, whether it is too far off path, too far ahead, too far behind of its position, it will trigger a stop. Mobius will then bring all of the vehicles to a stop with consideration for their individual positions and speeds. This is a feature we're very proud of in that it does make this a much safer effort. Also, Mobius does all of the coordination between vehicles, so human drivers don't have to be coordinating continually on radio for position, whether they are a meter ahead, a meter behind, or whether they are traveling the correct speed. This video is part of a promotional material that we've developed that speaks to the swarm function. The vehicle under test is the host, and all the other vehicles will constitute the swarm. That can be one vehicle, it could be 10 vehicles. But we do install a robot driver in each vehicle. This will provide us with motion and position for each vehicle and allow us to control them. We do automate the primary test vehicle as well. We will position the vehicles on the track, driving at speed and incorrect position, and then we turn over control to the ADAS vehicle. Mobius continues to monitor that vehicle as an autonomous safety rider. If the vehicle should leave its intended position by exceeding the tolerances given, then we will actually resume control, take control back from the ADAS system, and bring all of the vehicles to a controlled stop. Here's another section on the end of this video. You can see here that the vehicles can be commanded to move in swarm. And really, this is intended to test the responses of an ADAS-capable vehicle. I mentioned there were a couple. Our Smart Stop and the Autonomous Safety Rider are both patented processes. So Mobius is also capable of interfacing with other robotic drivers or with drive-by-wire capable vehicles. Currently, we're partnering with Stale Robots, Stela, Stale, depending on your pronunciation. But these are already implemented in some areas. We do have customers using hybrid systems. We can also control by wire configuration. There have been several transmissions, throttle, and additional systems that we have taken control of by wire to conduct the testing. And teleop is available, again, both as supervised and dead man operation. Mobius is constructed with a server client model, so you can have greater security and remote access. There can be multiple workstations where individual users can use and interface with Mobius while maintaining one central server that will monitor the position and maintain the safety parameters, so there's no unintended contact between vehicles outside of a user's span of control. Mobius allows also for specific user roles and associated permission levels. This allows you to break down what each user is allowed to do. An administrator can define those permissions for each role and then creates a position or a login for each user that is granted only those permissions. The construction of these user roles is very simple. The administrator can go in and simply using sliders can determine which functions the user is able to access. You may want to restrict an operator's ability to change a map or change a path if they haven't been trained to do so. They can simply assign and monitor vehicles. You could have a user that is able to change the configuration items on the vehicle. It all depends on what your administration and the safety of your site requires. As mentioned, we create a role which has the permissions, and then there is an individual logon for each user, complete with username and password. These are secured in order, and the administrator can change passwords, reset passwords, but these are set up so that each user is not only able to address only those items they should address, but may also be accountable for anything they should, their name is tagged with any actions they take so that in the event of an incident, they can be tracked. Mobius, you may have noticed I had different gauges for different vehicles in the convoy. Mobius has customizable gauges. We can create any gauge for which we receive telemetry from the vehicle. Typical gauges are going to be gear, wheel speed, and engine speed, but fuel, oil pressure, and warning lights could also be received as long as you can interpret those signals from the CAN. They can be set up and crafted so that they can be viewed on the main screen, or you can similarly pop out a screen of gauges and view those separate from the position of the vehicle. This is just a video. At ASI, we allow you to craft the tests and the parameters that you want for your testing. We acquired an older Jeep and decided to conduct some extreme end-of-life tests. Here's a view inside the vehicle being operated. We did the jump and then tried to roll the vehicle. Later found out a Jeep was not the correct vehicle to try and roll. We did blow tires off of bead a couple of times. But the point of this video is simply to make sure that we are demonstrating you have the ability to create what paths you want, to take the actions you want to test your vehicles. Thank you for taking the time to sit through this presentation. I hope it's been informative, and I'd be happy to address any questions that I'm able if anyone has any.